Hello, welcome back to Algebra 1. We're going to continue adding fractions, but in these problems, the denominators will not be the same. So how do we handle this? Let's say we have the fraction 1/2 plus 2/4. Now, you want to add these guys together, but you notice right away the denominators are not the same. I have a denominator of 2 and a denominator of 4, so I cannot add these. No matter how badly I want to, I cannot add them until these denominators are the same. So if you have fractions where they're not the same, you have to make them match somehow before you can add them. So remember I told you back when we simplified fractions that we could divide the top and bottom of a fraction by anything as long as we did it to the top and the bottom. Well, it turns out that you can do the same thing with multiplication. You can multiply the top of this fraction by any number you want to, as long as you always also multiply the bottom number by the same number. Because in that way you're keeping the fraction balanced. So I can, if I want to, multiply the top by 25 as long as I multiply the bottom by 25. I can multiply the top of this fraction by 7 as long as I multiply the bottom by 7, because then the fraction will look different but it will represent the same thing. So the question is, how do I multiply this fraction, top and bottom, so that the bottom will be 4? Because I want it to match with this. That's the easiest way to handle it, right? If I multiply top and bottom by 2, let's see what we get. So we have 1/2. Let's multiply the top by 2. We'll also multiply the bottom by 2. That's going to keep things balanced. We're still trying to add the fraction 2/4. Now when we do this, what we're going to have, 1 times 2 on the top is going to give you 2. On the bottom, 2 times 2 will be 4. So this problem basically is transformed into the following problem. Basically, this problem that we wrote down is the same as this one right here. And the reason is because 1/2 is exactly the same thing as 2/4. But now these denominators match, which is what we want. So we can continue by saying, all right, on the top, 2 plus 2 is going to be on the top, and 4 is going to be on the bottom. So we'll have 4 over 4. And you all know that fractions is another way of writing division. 4 divided by 4 is the number 1. So that's the final answer of all of that. So in order to get anywhere, you have to transform. In this case, we only had to transform one of the fractions because we could easily find the number to make it match the other one. But the bottom line is you need to be able to do something to one, or you may have to deal with changing both of the fractions to make the bottom number the same. All right, so let's take a look at 1/3 plus 1/6. How would we transform this guy? Well, I know that 3 times 2 is 6, so I can multiply this top and bottom of this fraction by 2 in order to get what I want. So 1 times 2 over 3 times 2. I'm still trying to add 1/6 to it. So over here, I'm going to have 2 on the top and 6 on the bottom. So that's 2/6 plus 1/6. Now I can add these fractions. 2 plus 1, I'm going to start doing things a little bit faster since we're adding fractions. 2 plus 1 is 3, so 3 on the top, 6 comes along for the ride on the bottom. Now I have to ask myself, is this fraction fully simplified? Because you always have to ask yourself that. No, it's not. 3/6 can be simplified by dividing the top by 3 and by dividing the bottom by 3. 3 divided by 3 is 1, 6 divided by 3 is 2, so the answer is 1/2. That's fully simplified. This answer right here, 3/6, is the answer. It's just that this is what you're going to want to write on your test because this is the fully simplified version of that. So you're only going to get good at this by working a lot of problems, so let's continue on down the line. What if we have 2/5 plus 7/10? How do we transform one or both of these fractions, if needed, in order to make the denominators match? Well, here I notice that 5 times 2 is 10, so I can make it match by multiplying this whole fraction by 2 on the top and on the bottom. So I can do that. It stays the same when I do that. I'm still adding, actually I need to erase a little bit here. This is going to be plus 7/10. So on the top of this fraction, I'll have 4. And the bottom of that fraction will be 10, and then plus 7/10. And now I can add them because the denominators are now the same. 4 plus 7, what is 4 plus 7? That's 11, and 10 will be on the bottom. Now I can totally circle this and say this is the correct answer, the final answer. That's totally okay. But I could convert it to a mixed number if I wanted to, because this is an improper fraction. The top number is bigger. So how many times will 10 go into 11? It's only going to go one time with a remainder of 1, and the denominator stays the same. So however you want to write it, both of these answers are exactly the same. So just write down whichever one you think is better. You can write 11/10 or you can write 1 1/10. All right, so let's go ahead and solve the next problem. This one will be a little bit different because we have 1/4 plus 1/6. Now notice in all of the previous problems, all I had to do was change this fraction to make it match to 4. Here I had to change this fraction to make it match to 6. Here I had to change this fraction to make it match to 10. Those are carefully chosen. But this guy, there's no way I can multiply 4 by anything to make it equal 6. So I can't just do one of these fractions. I have to do something to both of them. So what you're trying to do is figure out what number to multiply this fraction by to give me a denominator such that I can do something similar over here to get the same common denominator. We call it a common denominator in math. Well, I know that 6 and 4 will both go into 12. I know that I can multiply this times 3 and give me 12, and I know that I can multiply this times 2 and give me 12. So I'm looking for a number, in this case the common denominator I'm shooting for is 12, so that I can multiply this by something to give me that common denominator and this by something to give me that common denominator. So what I'm going to have is 1/4, and I'm trying to multiply in this case by 3 because I'm going to want a 12 for a common denominator. And then I have 1/6. I'm going to multiply this fraction. Notice I have to multiply this one by 2. So you see, you don't have to multiply these fractions by the same number. Okay, here I'm just multiplying, as long as you're doing it to the top and the bottom, I can transform this fraction, and this is going to represent the same thing that the original fraction represented, multiplying top and bottom by 2 here, multiplying top and bottom by 3 here. Why am I doing it this way? Because the first fraction is going to give me 3/12, and the second fraction is going to give me 2/12. You see, the entire point of this game is to get the same denominator. So you have to come up with some common denominator in your head. Because I know my multiplication tables, I know I can multiply to get each of these denominators to equal 12. Once I've done that, I add the tops. 3 plus 2 is 5. 12 goes on the bottom. That is fully simplified. Can't do anything more, so I'm done. All right? So it takes a little more thinking, but with practice, it really is not a hard thing to do. What if I have 2/3 plus 4/5? So I look and I say, well, these do not have a common denominator, and I cannot just monkey around with one fraction to make it equal 5. There's nothing I can multiply by to do that. So I'm going to have to do something to both fractions. And I look at these two numbers and I think, what is a common denominator? What can I multiply 3 by to give me that common denominator, and then also multiply 5 by to give me the same common denominator? Another way of looking at it is, what number is both divisible by 3 and 5? So I start going up. 10's not going to work because I can't divide 10 by 3. 12's not going to work. I could divide 12 by 3, but I can't divide 12 by 5. I keep going up, and eventually I hit 15, and I realize, well, 15 is divisible by 3. 15 is also divisible by 5. So 15 is going to be my common denominator. What do I need to multiply this fraction by to give the bottom number 15? I multiply 5 by 5. That's going to give me 15 for the denominator of that fraction. And then for the other fraction, 4/5, what do I multiply here to give me 15? I have to multiply the bottom by 3, and then of course I have to do the same thing to the top. As long as you're doing the same thing to the top and the bottom of each fraction independently, you're going to be fine. So for the first fraction, 2 times 5 is 10, 3 times 5 is 15. For the second fraction, 4 times 3 is 12, 5 times 3 is 15. Now I have a common denominator. So I can simply add the top here. 10 plus 12 is going to give me 22, and I'll have 15 on the bottom. And this is the final answer. I can leave it like that, but it's improper, so if I want to, I can say, well, how many times will 15 go into 22? It'll go 1 time, and the difference between 15 and 22 is 7. That's a remainder, and then 15 goes right there. So I can convert it to a mixed number, and we've covered how to do that in the past. All right. Now, let's go and do another couple problems just to give you a little more practice. We'll do some subtraction problems now. 5/12 minus 1/5. How do we handle this? Well, now I need to find a common denominator. What is divisible by 12 that's also divisible by 5? I start going up my numbers. I don't find anything super easy, but eventually I'm going to get to 60 because I know 12 times 5 is 60. but I also know 5 times 12 is 60. So 60 will work as a common denominator. So I have 5 twelfths, and to change this to give a common denominator of 60, I multiply 5 by 5, trying to get 60 on the bottom. Subtract 1/5. Now what do I multiply here? I'm multiplying 12 and 12, like this. All right, and so then on the first fraction, 5 times 5 from here is going to give me 25 over 60. The second fraction, 1 times 12 is 12, and again over 60. So now I have two fractions that are each have a common denominator of 60, and so I can just subtract the numerators. 25 minus 12 is 13, and then I have 60 on the bottom. And that's fully simplified. I can't do anything further with that. Okay? Now let's just do one final problem just to give you one last bit of practice because it's so important to be able to do this. What if you have 7/10 minus 2/15? I'm looking for a common denominator. What is divisible? What number is divisible by 10, but that's also evenly divisible by 15? That's going to be a common denominator. I'm starting to go up here and I see, well, 30 will work because 10 divided by 30 is 3, 10 divided by 15 is 2, so that will work. In other words, I can multiply this by something to give me 30, and I can also multiply this by something to give me 30. That is what I'm trying to do. So the 7/10, what do I multiply by to get 30? It's going to be 3, so I have to do it to the top and to the bottom. And then the 2/15, what do I multiply by on the bottom to give me 30? I multiply by 2, so I have to also do it to the top and to the bottom. So 7 times 3 is 21, 10 times 3 is 30, minus 2 times 2 is 4, 15 times 2 is 30. The purpose of this was to get a common denominator, any common denominator, and so I got 30 as a common denominator. 21 minus 4 is 17 on the top. The denominator sticks along for the ride, and there's no further simplification needed here. So make sure you can do these problems. I could keep working them, but essentially you're going to be doing the same thing over and over again. I know you've been exposed to this in the past, but it's very important for you to understand this so that when we move on into algebra and deal with fractions where you have x, y, and z in the bottom, you'll know what we're doing conceptually. So make sure you understand this. Follow me on to the next section. We will talk about how to multiply fractions together.